Hello, I am Amit Kumar Gupta and today I am taking the class on gravitation. So this topic, I have taken this topic from the class 9th NCERT book, chapter 10, Gravitation. So when we are talking about the gravitation, then these are the topics need to be covered. These are the important topics which need to be covered when we talk about the gravitation. So these are gravitation force, universal law of gravitation, free fall, acceleration due to gravity, mass and weight, thrust and pressure, and then buoyancy. So we will cover one by one these topics. So before starting this topic, we need to know what is the importance of gravitation. Why we are going to learn the gravitation? What is the important in our daily life of gravitation? So the basic definition of gravitation is it is a force of attraction between all the masses in the universe, especially in the case of when we consider Earth and other masses, then we could call it as a gravity. So gravity and gravitational force are just like a singular things. Okay, gravitation force act on all the bodies present on the universe, but gravity, when we consider Earth and other body, then it is called as gravity. Okay. Now we have learned the definition of gravitation force. Now second is universal law of gravitation. So there is a derivation, universal law of gravitation. Okay. So now we are going to derive universal law of gravitation. So force on two bodies is directly proportional to their product of their masses. Suppose there are two bodies and these are two bodies. One is a bigger bodies, we denote it as a capital M, and other is small body, we denote it as a small m, and the distance between them is d. So force between two bodies is directly proportional to product of their masses and inversely proportional to the square of the distance between them. So when we combine these two equations, we get force is directly proportional to product of their masses and inversely proportional to this. And when the proportionality constant, we remove proportionality, then there is a proportionality constant G, m upon d square. G is a constant and G is called now where F is force of attraction. Okay. M is mass of bigger object. Small m is mass of smaller object. G is gravitation constant. This is a constant and its value is fixed. Its value is 6.67 into 10 to the power minus 11 Newton meter square per kg. Okay. Now we need to know how we get the unit as a unit of this G. So from here, from the formula, we can calculate the value of G. Okay. F d square upon mm. Now put the unit of SI unit of each quantity. Force is Newton, distance is meter square, mass is kg into kg, that is kg square. It will convert it into Newton meter square kg power minus 2. This is the formula for universal gravitation constant, and this is the SI unit of universal gravitation constant, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg. So this is universal law of gravitation. Okay, force is directly proportional to product of their masses, and force is inversely proportional to square of distance between them. And when we combine these two equations, we will get this. Okay. So we have covered this topic. Now move toward our next topic, free fall. free fall. So from the name itself it is clear that any object which is falling free without any force is called as free fall. Suppose this is a marker. When we leave it from a certain height, just like this, it attracts the earth. Earth attracts the marker without any external force. Only one force is acting on it. What is that force? Gravity. Because of gravity it goes down. Okay, so free fall is a force. Free fall means when any object, so when object fall towards the earth under the effect of gravity alone, then it is called as a free fall. Okay, now acceleration due to gravity. This is a very important topic, acceleration due to gravity. It is also denoted by small g. Okay, now we have to derive acceleration due to gravity. So when an object falls towards the earth, then there is always an acceleration. So this acceleration is called as acceleration due to gravity. When an object, suppose this is object, and when object fall towards the earth, then there is an acceleration. This acceleration is called as acceleration due to gravity. Now how to derive the acceleration due to gravity? We know that F is equal to mg. Okay, and we already derived the formula. F is equal to g m upon r square on d square. And there are two masses m. Suppose we take this formula for considering earth. So the radius of earth is r and the mass of earth is m. Okay, so this formula we can write it as gmm upon r square. Combining these third and fourth equation, we will get mg is equal to gmm upon r square. We can cancel g and m, then this will convert into gm upon r square. Okay, we already know the value of g. We already